Now, like in other chapters, the authors offer a focal issue to think about the importance of the hydrologic cycle. And they state that human activities have substantially altered Earth's hydrologic cycle at regional to global scales. Where this becomes important is that currently 50% of Earth's available renewable fresh water, so again focusing in on fresh water here, and it's 50%, so half of the world's fresh water, and up to 100% in some regions, goes to human activities. Now, often this water gets used for agriculture, and that's a huge, huge use by humans of fresh water. But also we alter the hydrologic cycle, as we'll talk about, by changing the plant communities there. And there's a much different cycle associated with grassland, for example, as far as the amount of water that comes off and the energy balance associated with that grassland compared to tree plantations that we might plant where there once was grassland. And understanding the consequences of planting trees in what was formerly a grassland has to do with the changes in the energy balance between the two systems and how differently these forests use water than grasslands. These changes in the appropriation of water and changes in plant communities, for example, are strong enough to alter the regional climate. The example that the authors give of this comes from Australia, and this shows wheat fields in areas where the vegetation was once heath. And heath is a low fertility environment, not necessarily a lot of plants there. It's not very productive compared to the wheat fields that have been planted adjacent to it. The difference is that you see here, you can tell that there's a lot of clouds over the heathland right here, but not a lot here. And the reason is because of the differences in the way that energy and water are partitioned between the heathland and the wheatlands over here. So the heathlands, for example, do not transpire as much water. They're less productive than the wheatlands here. And because they don't transpire as much water, they actually get hotter. And that causes air to rise above the heathlands. These wheatlands actually transpire a lot more water, and it generates a lot more water vapor over it. But because the air is rising a lot more so over the heathlands than the wheatlands, that sucks up air off of the wheatlands into the heathlands. And this air is laden with moisture. When it hits the heathlands, it gets heated up and rises. And when that air rises, filled with water vapor, that water vapor condenses and forms the clouds that you see here. So a simple change of plant communities from heathland to wheatland and the differences in productivity that we see changes these regional climate patterns with a lot more production of clouds over the heathland because of differences in heating and water balance. We're going to talk a lot more about the details of how this can arise and use this example again later, but it's important to know that changes even in plant communities alone, without direct changes in the way that we use water, such as irrigation, can have really big effects. Some of the questions that we really think about when we focus our attention on the water and energy budgets of ecosystems is really thinking about how much precipitation is needed to meet ecosystem function. So if there are changes in precipitation, for example, how is that going to impact ecosystem function? And at what point do we get a categorically different ecosystem function when precipitation changes? They also state that it's important to think about what determines partitioning of water available to humans. So if we rely on stream water, for example, or river water, what determines how much of the rain that comes down into an area gets partitioned into streams versus transpired or evaporated back into the atmosphere? And this is really important because there might be things that we do that affect that partitioning that's going to change, either increase or decrease the amount of stream flow. It's also important to think about the consequences if water availability is reduced. So we might do things that change water availability to plants in different ecosystems. And we're not quite sure what the consequences of that change in water availability is. If we reduce water availability, if it gets drier because precipitation changes from something that we do, or we change stream flow patterns, for example, or move groundwater out of a system, what are those consequences going to be? And it's only understanding and integration of the energy and water budgets can we start to understand the answers to those questions. As a last point, they note that water vapor is the major greenhouse gas. Now, they don't say that it's a major greenhouse gas, it's the major greenhouse gas. We talked about it before that water vapor has strong absorbance of energy, and as a consequence, it really absorbs a lot of energy and heats up the atmosphere to a great degree. As a consequence, thinking about how much water goes into the atmosphere is really important for thinking about the temperature of the Earth's climate. Within this, they talk about the water vapor feedback and how warming, for example, if it increases evaporation, can serve as a positive feedback to temperatures. And so really even just focusing on one critical aspect, how much water vapor is entering the atmosphere, has important considerations for global climate. And they talk about the water vapor feedback in the introduction just a little bit.